morning. Today I'm going to be, I don't have a lot of time, just a little bit over an hour, and then I've got to do other stuff all day. So today I'm going to be working on organizing the repository. I've got several tasks. I'm going to update how I'm going to update the stream on how I am rendering the particles because it turns out I was, as expected, doing things backwards. I'll explain that in a minute. Basically a Fortran C ordering type thing, if you will. Then I'll be organizing the repository a little bit while I experiment with different ramping functions for the massive black hole. The idea here, again, is to have a stellar cluster, black hole at the center, and then we'll watch as the stars start to orbit around it. So ideally, we'll start out with in the past. What I've been doing is I've been starting out with it already with the massive black hole already there. Now we're going to work on ramping it up. So we're going to see the stars sort of move around and then all of a sudden start coalescing. Okay. First thing I'm going to do is I'm going to talk through a little bit about how I had been doing things and how I have now modified them. So, in the past, including as recently as yesterday, what I'd been doing is I've been loading in the CSV files, and then I had been using attributes on those, and then changing the position of an individual object. What I'm going to be doing now is, and what I've changed all the scripts to do, is to instead take each of those vertex points, I should also mention that I was manually then updating a path, so I'd have to like keyframe in between and all that. Turns out I was working at cross purposes to the way that Blender likes to do things. I actually did this like, I don't know, a year ago or something when I was first experimenting with Blender. What I did was to utilize the paths and curves and all that stuff. So I'm going to go ahead and do that this time. So here instead, and I'm going to show you how I'm doing stuff, I'm now opening my two scripts here. First we'll load Grid Creator, which I'm going to change the name of in just a minute, and then load orbits. So you'll see here, inside Grid Creator, what I'm doing now instead is I am taking the vertices, turning them into a set of points, and then taking those points and turning them into a curve. So I'm going to run this, and then we will. So this creates my geometry nodes. Now I'm going to run my load orbits script, and it's entirely possible I could run both of these in the same thing, but I have not totally worked out how to do that, so we'll work on that in a minute. We run this, and you'll see it's now taking a lot longer because I did something a little bit silly, and I changed the simulation to output every month or so for 10,000 years, and so it's pretty crazy the degree to which it's now over-resolving these orbits, but we'll get to that in a minute. So it takes a minute, loads it all up. Today also I'm going to start out by listening to Ween the Mollusk. It's a real desert island disc for me. Let's see, I wish I'd put in a progress bar here so that we could see where it was getting to. That's one of the things I tend to forget the first couple times I do something that occupies a lot of time in the in something like this. So I'm just going to vamp for a minute while it goes through this. But we can also maybe get started with our star cluster modification. So here what I'm going to do is we will, let me see, nope, sometimes my TTYs get messed up, so let's do this. We're going to try running a simulation that. Here we will do run simulation. We're going to run another simulation, and this time I'm not going to put a black hole in there. Black hole mass equals 1, and stars equals 50. And this time we will output every 10 years. And we'll have a velocity factor. We'll just let this be equal to 1. Ah, there we go. I'll come back to that in just a minute. Let me run this while it's going. Let's take a look here. So now the geometry nodes, instead of what I had been doing, what I've done is I've separated it out into positions from CSV. Now that's not really quite the right name because really the positions are in the attributes of the grid objects, or of the meshes. What I'm doing is I'm taking named attributes, combining them X, Y, Z, and then I'm taking the mesh, turning them into points, calling set position on that. And so now every single vertex point in the geometry gets set to have its position to its attribute. Let's see if I can show what that. I'm not sure that I can. Let's see, how do I show how that looks? Yeah, I guess I can't because the spreadsheet view just shows the end result. It sets the position, turns those points now into curves, and then what I do is I sample the curve from 0 to 1. So here I've got a map range, so that ties it to the animation. But now here, if I change this, you can see now I'm manually updating the factor, and it is now sampling along the curve. But what I've input here is I've input the animation scale, which is how long I want the animation to last in seconds. And then it takes the scene time in seconds and maps that from 0 to 1. So it samples along the curve path and then updates the position. Each one of these objects then has a UV sphere associated with it. And if I shrink these way down, you'll see this. And so if I set my animation scale to be 300 seconds, and then I can't remember how to set this to seconds instead of frames, but let's say 300 times 30, I guess, yeah. So let's see, we actually want 24. So let's do 7200. So this is a pretty long movie, but we can watch this now. And you can see them all sort of moving around. Some of them started pretty close in because I used the wrong distribution function. So we'll come back to that later on, but got way too many very close in. Okay. Let's go back here. Okay. So let's take a look now at how we can update this. See, they're still moving. So now it's doing that. We've got a new set of simulations here. So let me show you what it looks like if I reset this. Now, one of the things that I want to do is I want to set it up so that all the new orbits get added into collections. We'll deal with that in just a minute. Let's reload our orbits. Go back here. Oh, that's odd. Oops, it's reloading the exact same one because I never reran this. So this will reload 220 snapshots to CSV files. I didn't really get the my display correct here, so we'll deal with that in a second. This is the exact same results that we had before because I didn't re-update them. So let's go back to scripting, load orbits. And now what we should have is we should have just a bunch of stars that sort of gently move around. Yeah. Why are they all seem to be moving outward. I wonder if I mixed up my orbits, mixed up my directions. So let's make them go a little bit faster. We'll run it there. Now let's export. Here we go. Rerun. Geometry nodes. Alright, so now we can see they're just sort of floating around. There's not a ton of mass in the cluster, so there's not a lot of interactions that we see, but we can start to see some of them, have curving paths and whatnot. If I up this to, well, let's say 500 stars, let's see what that looks like. And now one thing I'm going to also do is I'm going to not shift the, I apply a shift, which makes sense if you're doing a central massive black hole, but here we're not. So I'm going to turn off the shifting. And then we'll get to ramping up our black hole. So in my load orbits, what I want to do here is I actually, you see here we've got this object that gets created by the load orbits. I want to see if I can add that object to a collection. If that collection exists, then we will update it. If it doesn't, we won't. I'm sorry, if the collection exists, we'll delete everything that was a part of it. So let's see if we can do this in here, inside our scripting interface. We'll experiment first here. So bpi.data.collections shows all the collections. So there's blend data collection. I'm going to create a new collection. We will call this. So if I take a look at this, see we've got bpi outline collection. If we look now at bpi data collections, 0 is collection, number 1 is there. If we look at name, I should be able to change that name to orbits, and it does. So let's see now. In the scripting interface, can I do bpi data collections dot, is it items? Let's see, children. Nothing under the children. Oh, so I guess that's not the right way to access it. I guess it's all objects. So do I just delete? Nope. Let's check what that. Oh my goodness! Look at all of those. Let's see. Delete. Oh, it's got a CSV associated with it. That's fun. We are actually, though, just going to remove them instead of try to update them. It is possible to update. We're not going to do that because, well, I mean, there's not really a good reason not to, but we're not going to. Is it remove? Rename? So let's see, all objects dot unlink. Okay, so I should be able to do this. So let's modify our load orbits here. So let's do this. For collection in bpi.data.collections, if collection.name equals orbits, for object in collection.objects, bpi data.object. Wait, what? bpi.data.objects. Oh my goodness. All right, well, that's the easier way to do it. And do we call remove bpi.data.objects.remove? Yeah, wow, okay. So let's go back here. Let's move my terminal out of the way. For object in bpi.data.objects, if object.name.starts with orbit, let's see, is it orbit CSV? CSV underscore orbit. bpi.data.objects. Remove object. Okay, and now let's see, how do I move this? So I think I use bpi. Hold on. This should get us where we want to go for now, so let's try that. Reload from disk, run it, it deletes and re-executes. Okay. Now to test this, I'm going to rename this object. And then here inside my execution, we'll export all our 500 stars. And now I should be able to run this, and it should delete this one and add in the other 500. Looks like it did. Okay, now let's take a look at how this looks. All right, it's going super slow. Let's see now. How do let's change my animation time here. Let's change my animation scale down to, well, let's say 30 seconds. So now if I play it, now mind you, I wonder if this is crashing my, yeah, this is really dragging on my rendering time here. There's probably a better way to do this, but as I've shown before, I'm not always going to get things right the very first time. So if I play this, okay, neat. So yeah, the cluster is slowly evaporating, which is what we would expect with random velocities. Without a big central point mass. Okay. So now let's get back to organizing our objects. We actually want to now link them all into our main one. So what we'll do for object in bpi.data.collections 0. So let's first check if we have a, if not any, bpi.data.collections. If not, hold on, why am I doing this in Blender? I don't want to do it in Blender. I want to go back over here to Visual Studio Code. So now we check if the collection orbits exists. I don't think that's what I want to do, because I don't think it'll check that. Collection in bpi.data.collections. True. Oh my goodness, it does check for string keys. Great. All right, if orbits not in, now we create the collection orbit if it orbits if it doesn't exist. Now, what did I call to create a new collection? Let's see, new? Yeah, new. It just takes a name. Okay, so let's get a name. New orbits. Can I do this? bpi.data.collections collection. Can I use a string key? All right. Yeah. There we go. We'll just do an else. We'll gate it like that. New objects. So that. For new objects in objects. And actually, for new, no, for object in new objects. Can I check if it's in a collection? If object in that's not what I want. bpi dot data dot collections collection. Let's link it first in case there's any type of garbage collection. Okay, so now let's reload this from disk. Let's see what it does. In principle, it should load them all in. Traceback. bpi struct contains a string. Oh. So it did create all of them, I think. Let's go on down here. There's probably a better way to group stuff, but I'm just going to keep them in collections for now. Yeah, it did link it. So it linked it first, and then it was if object in. Yeah, okay. If object in bpi data collections. All right, there we go. Dot objects. That's not where I want to make the change. Did I get a trace back? Line 30. It's a dot name. Take my repose. right, so now, oh good, I did not get a traceback. So now we're doing this nicely. We add in to our orbits. Now, a few things that I'm a little bit unhappy about in how this is working is that I've got a radius that is scaled based on not an attribute, but just a global variable. We'll see if we can fix that at another time. I think the best way to do that would be to then, oh, this could be cool. We could either have a mass associated with it, which is probably where I'll end up having to go. I mean, that's definitely where I'll have to go for the black hole, but it might also be where I have to go for the stars. But let's see if we can. Welcome. Good to see you again, Ethan. Let's put you up here. All right. So we're going to try to incorporate these two things into the same file. Now that's going to be fun. Let's see if instead of calling this load orbits, let's do Python file. We will save this as orbit visualizer. Simulated orbit visualizer. Now let's load our load orbits here. We'll put that in first. Now let's load in here. Now let's try this. So orbit path. I have to say, I don't know if classes have started for you, but ours start next Wednesday, and I am looking forward to not being on time. No, that's just a joke. I'm nervous about how cold it's supposed to be next week while I'm still supposed to be on time for all my classes. Because the scheduled, we have, much like New York, but 90 degrees flipped. We have really good east-west service on our buses, but not great north-south. And so my house is directly east of, or directly west of where I work most of the time. But unfortunately where I'm teaching is a fair bit south of that. So I am anxious about the cold and all that. I don't know. I guess I could find something to be anxious about wherever I am. So let's see. I've got Blender set up. Let's do a new one here. We'll go into scripting. Let's delete our cube. Yeah, take that, cube. Oh, is it about my cube? Let's see if we can run everything inside. Dang. Nope. Oh, I see why. We got to do this in the right order. So the first thing we do here is we put all of our grid specifications up there. It's down in the high 40s. Oh, goodness. I sure hope that's Fahrenheit and not Kelvin. Here it's, let's see, today, right now, it is -1. According to my watch, Google says it's 3. The wind is only 4 miles per hour. It's supposed to get up into the teens this afternoon. Teens are actually around the time when I'm going to thinking about taking the dog on a run later today. I can go running in the teens mostly, but I haven't taken our dog's now 2 and change. I think she'll be okay, right? Yeah, she'll be fine. Okay, so I got an issue. Key animated orbit not found, but I define animated orbit right here. Let's see. Let's try new general. Don't save. Scripting. So this should do everything. It should create my tree here. this will, apply gravity and all that stuff. And I'm actually going to get rid of this apply gravity inside this particular um, setup because I don't. This is going to be a separate thing from my gravity experiments. And part of what I want to do today is organize this repository. So let's try this. Let's try executing here. Now, if I get a trace back, it should be much more visible. Let's see what exactly happened. Didn't get anything. Let's try not unlinking these and see if that, because it's possible that I'm doing something wrong with the way that the orbits are being linked. So it's loading them in. It's not correctly creating my orbits collection. Oh, I think I probably have to add the collection to the scene. So it's probably, yeah, okay. Item has no users and will be removed. Okay. So, let's go down in here. Oh, and let me get rid of the stuff I don't need here. Positions from CSV don't need. Grid as points don't need. Animated orbit need that. Gravity input don't need. BPy scene dot collection. Yeah, okay. Well, let's see if Copilot gets it right. New general. Don't save. Scripting. Open. Let's see. Dang. BPy has no attribute seen. Scene collection children link. BPy context scene collection children link. Okay, there we go. All right, context collection children link. So now, wait, I forgot what I did. Context scene children link. All right, let's try this one more time. Okay. All right, I've got my orbits in. I forgot to turn off shifting, but that's okay. Now, group input geometry. Okay, let's move on to getting the mass in. Got this new file. Let me real quick also commit this file. Okay. So let's tweak our simulation a little bit now. So in the past, I had done various different ramping functions for the massive black hole. You know what, before I get to that, let me put the mass in this. It's actually masses. So it goes time, mass, x, y, z. Okay. And now let's also increase, well, right now it's not doing a ton of distribution in the masses. But let's tie our okay. Remember, I don't need to do that. So let's go back here. We will rerun our script in just a moment. Shman, take me by the hand, lead me to the land. Okay, so we've got time, mass. Mass is not changing. Good. Here, let's rerun this. And now all of our geometry, and let's see if I can see the actual input spreadsheet. Oh, this should go so it probably didn't do anything because it threw an error on this. Okay, let's reload this. So now it'll only link it to the main collection if I am creating it new. All right, so let's see. Can I see? Let's take a look. So now, group input, 3 named attributes. You know what? Let's do here positions from CSV. Let's take our we'll capture a named attribute. No, that's not what we want. We actually want to just read a named attribute. Mass. So now, and we'll see later on how this works with, and we'll rename that. Why is that an invalid link? The node input does not support. Translate geometry. Yeah, so this named attribute actually has to be stored on my curve. So set position. Value. And this goes on to a point. So we'll do that. So now there should be a mass associated with it. Okay, so now if I go back out here, position, sample curve. I may have to sample twice on this curve. It'd be easier if they were constant math, but I can't make that assumption. Points to curve, sample curve, we'll sample both. Oops. Value goes out with the attribute, but we actually need to sample. See here, we're sampling the position on the curve. Oh, you know what? I'm not sure I need both of these things, so let's come up with a value. We'll input our value that we're sampling. So this will be a read named attribute. Okay, so now I should be able to look at this. Okay, so that looks like it might be working. Let's do a mapping. We'll take our input attribute, and we will take our min and max. Let's do utilities, and then I'm going to convert all this back in. We will do a map range from our min, from max, and then we will take our radius value as our input, and then our output, go back into radius. Well, that didn't really work, did it? Oh wow, it's mapping it from 0 to 0. Let's take our geometry. No, but we can't do that, can we? Because this is just for our local values. All right, well, I'll just do mapping range from 0.1 to 5, from, we'll do 0.01 to 1.5. Okay, so now we see we do have varying mass. Now, there's probably a way that I can scale all this around. Oh wow, I can't believe that I already finished my Ween album. Onto Garbage, one of my absolute favorite albums of all time. Garbage 2.0. Although I guess I probably said the exact same thing about the Ween album, didn't I? Okay. 4 named attributes. So let's update now. Positions from CSV. All right, so now we've got to add in our named attribute M. So let's go back here. Inside positions from CSV, we got to add another M equals gs.named attribute. name equals M attribute. Well, that's that right there. Now we feed that into value. And now we output value. So now we return a dictionary. Position. Okay. But we still need now to add in this store named attribute. Yeah, I need to store the attribute. So that is important. So after the set position, we've got this. So points. Is that line too long? Yeah. So now on the output of points, the geometry from that, we feed that into store named position, or named attribute. Geometry equals points. No, value does not equal gs.index. And that's name. Yeah, okay. Okay, and now that should do it. All right, so this should update that. And then let's check our animated orbit. Positions from that. You know what? I will go ahead and ignore this for now. We should just get an attribute. And so now let's go back to scripting and let's see if we can rerun this. Probably throw an error. Geometry node socket has no attribute geometry. That's line 27. All right, well, let's get rid of that then. Let me see where that error happened again. Geometry can express position M as of type node outputs as a node socket. Do I need to have group output? Yeah, okay, so I can't just return sampled. If I return just sampled.position, what's that do? Let's take a look at my geometry nodes. Let's go on into positions from CSV. All right, well, let's come up with a group specification. Oh, and I can get rid of this, huh? Class individual orbit ns.output group. Well, I guess it's an input group. Okay. Let's see, is this a float? Let's give this a shot. What did I call it? Individual orbit. Ba 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 ba. Maybe that's what I have to do. Let's give that a shot. Do I return a tuple? All right, time to go to the documentation. .config blender. Nope, that's a different add-on that I've been exploring, which I'm not going to do today. I'm going to have to hop off in just a minute. Let's see. Let's take a look at these examples. Do any of these return multiple? No, none of them do. These are all the example scripts. So here it's just returning grid.instance on points. Let's do the tutorials. So let's see if it says anything about why you would yield instead. Oh, using curve to mesh would turn the input curve into a flat mesh. To join the curve mesh and the building mesh automatically. What? Okay, that didn't really clear anything up. Thank you. Have a good meeting. Thanks for coming by. Sorry I couldn't get this a little bit more finished. So this is where it takes inputs. come back to this. Attribute sampling could be a lot easier, I think. Oh, all right, so I yield. All right, well that makes... So yielding is how I return multiple values. Or not. I can yield one item. Somebody get me out. I'm tearing up my skin. All right, so now we're yielding a radius. Or we're yielding a mass. But this doesn't work. Cannot express value of type socket value. Sequences of dimension 0 should contain 3 items, not 2. You know what? Let's see. Maybe I can print something out. Am I going to get anything here? Nope, I'm not. Oh, maybe up here. Lay the blame on me. Alright, so value. Geometry node socket class cannot express value. Alright, well, it's not supposed to be a geometry node socket. Yield sampled dot value. Yield sampled dot position. It's not a geometry node. I have run you down into the ground. Okay, I'm gonna have to hop off in just a minute, but this is starting to bug me. Oh. Maybe this is where the error is. Yeah, that's where the error was. Awesome. Okay, so maybe I can finish this. Let's see, where... let's take a look at animated orbit. Positions, result 0. All right, how do I change the names? Translation. You know what? Let's go back to what I had been doing. Returning the dictionary. All right, let's go back to yielding it. We'll figure out how to rename these a little bit later. Position. Okay, that did it. So I can return a dictionary. The problem wasn't even in the issue that I was seeing. It was, okay, or it wasn't even where I thought it was. All right. Okay, now I'm going to quick commit all this, and I gotta head out. Uh-oh. Yeah, there we go. Did I already did this, or add this? No. -m, fix collections, and map mass. Okay, got that one. Now let's also do this one. Here, I'm going to real quick export mass to. All right. So now, looks like I've got, yeah, there we go. All right, so now I've got a mass map. All right. All right, and, ooh, my camera's off. Or rather, my camera crashed somehow. Okay, thanks everybody for coming. I managed to reorganize a fair bit of the script, get a bunch of things put back in as what I needed to for automated all of the orbit collections. So I'm going to call this quite the success today. Unfortunately, I am unlikely to get to do much more on it today. All right, thanks. Bye.